Okay, in class we were working on this problem. We were going to find the exact absolute minimum and maximum of this function. And we decided that our general strategy will be that we're going to find the critical numbers of the function, and to do that we have to find what the derivative is and then set it equal to 0. That will lead us to the critical numbers of this function. And then to find max and mins, we're guaranteed that there will be a max and a min because we're on a closed interval. So after we find the critical numbers, then we test the critical numbers and the endpoints, because it could be happening here also, for where those max and mins are. Okay, so the derivative, first finding the derivative, f prime of x, this part we did in class. This is product rule, x e to the negative ax times negative a plus 1 times e to the negative ax, and we're going to set this equal to 0. And so we're going to factor out an e to the negative ax, because both terms have that, and we're left with negative ax plus 1. That equals 0. We know that this can never be 0. E to any power will never be 0. And so our 0 must be coming from here. So where is a negative ax plus 1 equal to 0? And remember that x is the variable. That's what we're solving for. We want to find the x value where this expression here is equal to 0. So we'll solve for x. So negative ax equals negative 1 and divide by negative a. So at x equals 1 over a, then the derivative will be 0, so this is a critical number. So we just need to test our critical numbers and our endpoints to find out where the largest value of the function is happening and where the smallest is. And let's see, so x equals 1 over a is our critical number, and x equals 0, and x equals 2 over a are endpoints. F of 0 is pretty easy to find out that that's 0. Okay, x equals 1 over a. So let's zoom in on this. F of 1 over a, we just have to plug that into the original function. So that will be 1 over a times e to the negative a times x, which is 1 over a. This is 1 over a e to the, okay, so negative a times 1 over a is negative 1. Because this is just like, if you put that in the numerator, you'd have negative a over a. So that we have negative e to the negative 1. So this is like 1 over a times e. Okay, we're going to leave that just as it is for a minute. And let's go down here to x equals 2 over a. So we want to find out what f of 2 over a is. And this will be 2 over a e to the negative a 2 over a. And that becomes 2 over a times e to the, this power on e, it's like negative 2a over a, so that's negative 2. So this equals 2 over a e squared. And we're told early on that a is a positive number. So a is a positive number. So this will be a positive number. This will be a positive number. Because of that, we at this point know that x equals 0 will have to be the minimum of our function. So this is our absolute minimum. And again, the reason I know that is because this is a positive number and this is a positive number, and 0 is smaller than any positive number. Now we just have to figure out which one is bigger, 1 over a times e or 2 over a times e squared. And I don't know. So one way, so we want to determine which is bigger, 1 over a to the e or 2 over a to the e squared. And so I'm running out of room over here. So let's say 1 over a to the e, or 2 over a e squared, which is bigger, because that will be our absolute maximum. We know the maximum has to either happen at an endpoint, at a critical number or an endpoint. We already know that this guy is a minimum, so we just have to figure out, sort of reasoning through some things, which of these would have to be bigger. And so 1 over a times e is like 1 over e times 1 over a. And this number over here is, I'm going to pull out a 2 over e squared times 1 over a. The reason I do this is we're going to be able to compare these two numbers. 1 over e is just a number and 2 over e squared is just a number. So we have a number times 1 over a and another number times 1 over a. And so I'm going to go ahead and evaluate what 1 over e is and what 2 over e squared is, just with a calculator. So just with Desmos, I found out that 1 over e is 0.368, and that's times 1 over a. And then with Desmos, let's do 2 divided by e squared, and I get that this number is 0.271 times 1 over a. Okay, so I have 0.368 1 over a's, or I have 0.271 1 over a's. Again, a is a positive number, and so this will be some positive number, 1 over a. And so I have 0.368 of them here, and I have 0.271 of them here. This has to be a bigger number because I have a larger share of the number 1 over a. So this is larger, and that has to be my absolute max now, since it's bigger than the other guy. So this is the absolute max. The absolute max is happening here at x equals 1 over a. So we have an absolute minimum and the absolute maximum here. So this did take a little bit of, the x equals 0 was easy to figure out, but you do have to kind of think through, okay, if a is positive, and once things simplify a little, and I can find actual numbers for certain parts of these, I find those numbers and find out what is a greater proportion of this other expression that I can't break up anymore, the 1 over a.